Namaskar. So, in today's session we will discuss about one very important technique for solving the electrical circuit, that is star delta transformation, and then we will proceed for our mesh analysis. So, now let us see what do you mean by star delta transformation. Generally you might have seen that the circuit is not so simple where you have only the resistors or inductors or capacitors in series or in parallel, but it is a combination of series, parallel, and sometimes it is having a different shape. Say in this particular circuit, if you see, the circuit is called a bridge circuit where the resistances are connected in bridge, and hence this is not either series or parallel. So, in these cases the simplification of this circuit can be done by using 3 terminal equivalent of the networks. What do you mean by 3 terminal equivalents? Basically those circuits which are in the form of Y or T or delta, or alternatively you can say pi network, are generally considered as a 3 terminal networks. Now, if you see this particular figure, this is a Y or you can say this is a star circuit where you see the resistances are connected in star form. At the same time you can also, if you stretch it a little bit, it will become a T network. So, basically the star or T are same type of circuits. Similarly, if you see this particular figure which is delta, their resistances are connected in the triangular format. If you expand or if you twist a little bit, you can convert that delta into a pi format. So, essentially delta and pi both are same, the only thing is that the change in the orientation of the elements. So, now in all these circuits what you can do, you can create the terminals like 1, 2, 3, 4 in this case, and similarly for T also you can write the names of the terminals like 1, 2, 3, 4, and for delta or pi also. Now, these circuits are you can see them either part of very large network or they can be the circuit themselves. Now, the question is that how to solve it. Now, if you convert delta to star, then sometimes it is more convenient to work in star than in delta, and you can solve the circuit which contain delta configuration. So, what does it mean? It means that the circuit which has one particular segment in delta formation and it is difficult to solve, you can convert that delta formation into equivalent star, and then you can solve the circuit which is more convenient to get the answers. Now, what you have to do? You have to superimpose a star network on the existing delta network and find the equivalent resistances in the star network. So, what you will do? You will put that star into the delta and you will compare the equivalent resistances which you will see through these terminals, and you have to just equate them, and you will get the values of equivalent star or equivalent delta circuit for the system. Now, what we have to do? We have to first try to convert delta into star. So, in this case what we are going to do? We are going to find the value of equivalent resistances seeing through these two terminals for delta as well as star. Now, if you see the star, the equivalent resistance seen through this particular terminal would be R1 plus R3, right. And if you go to the delta circuit, the equivalent resistance would be RB, and RB will have parallel of RC plus RA. So, that is why R12 for delta would be RB in parallel with RA plus RC, and R12 in star would be simply R1 plus R3. Now, the condition for conversion of delta into star is that for the equivalent resistance seeing through both of the terminals, the value of equivalent resistances should be same. So, that means that you have to equate R12 for star equal to R12 for delta. Now, if you put the values of R12 star, we got R1 plus R3, and for R12 delta, that was RB in parallel with RA plus RC. So, if you simplify, then it will become RB into RA plus RC in bracket divided by RA plus RB plus RC. Similarly, for R13 also you can write that is value would be R1 plus R2. R13 means if you see from this side, so you will see by seeing from this side the resistance would be R1 plus R2, and for the delta configuration R13 would be RC in parallel with RA plus RB. So, this will become RC into RA plus RB in bracket divided by RA plus RB plus RC. Similarly, for R34 you will have, for star you will have resistance equal to R2 plus R3, and for delta you will get value as RA in parallel with RB plus RC. So, that will become RA into RB plus RC divided by RA plus RB plus RC. Now, if you subtract equation 4, that is this equation, from equation 2, that is this equation, so what you will get? You will simply get R1 plus R3, that is you got from here, minus R2 minus R3. So, what you will get finally? Finally, you will get R1 minus R2, and if you simplify these two terms, if you take the negative of this and add into that, you will get RB RA plus RC. Denominator will remain same because that is RA plus RB plus RC, minus that will be RA RB minus RA RC. Now, RA RB you will get from here, RA RB you will get from here, and it will cancel out. So, finally, what you will get? RC would be common in both of the cases, RC you can take out, and then finally, you will get RB term. Basically, if you expand it, it will become RA RB RA and RB RC. So, you finally left with these two terms, and if you take RC out, then finally you will get RB minus RA divided by RA plus RB plus RC. Now, this is what you got from R1 minus R2. So, from equation 2 you have R1 plus R2 is equal to RC into RA plus RB divided by RA plus RB plus RC, which you have from here, and the next which you have just calculated is R1 minus R2. Now, if you add both of them, what you will get? You will get 2 times of R1, because if you add both of them, it will be 2 times of R1 is equal to RC RA plus RC RB plus RC RB minus RC RA divided by RA plus RB plus RC, right. Now, these two terms will cancel out, you will get twice of RB RC. So, 2 will cancel out from both of the sides. Finally, you will get R1 is nothing but RB RC divided by RA plus RB plus RC. Similarly, for R2 also you can calculate, and R3 also you can calculate the values of equivalent star for the delta connected network. So, in delta connected network RA, RB, RC are the components, and you will see that in these three the only delta components, the circuits component are coming. Now, the important thing is that you need not to memorize the above equations, because if you follow the simple conversion rule, you can easily get the value of R1, R2 and R3. What is the rule? Now, in each resistor in R, that is star connected network, each resistor is the product of the resistors in two adjacent delta branches divided by sum of the 3 star resistors. What does it mean? It means that if you put the star inside the delta, you will get this kind of circuit where RB, RA, RC are the branches of delta and R1, R2, R3 are the branches of star. So, if you want to find out the value of R1 in terms of the delta branches, what you will do? You have to simply see what are the delta branches is adjacent to R1. So, in this case it is RB and RC. So, for R1 the value would be RB into RC, that is the multiplication of the adjacent two branches, divided by RA plus RB plus RC. Similarly, for R2, if you see the adjacent branches across R2, those are RC and RA. So, what you will get? The value of R2 would be RC into RA divided by RA plus RB plus RC. Similarly, for R3, the adjacent delta branches are RB, RA. So, RA, RB is the term which will come in numerator and divided by RA plus RB plus RC. So, if you follow this convention, you need not to worry about how to memorize the formulas for R1, R2 and R3. Now, let us talk about star to delta conversion. Now, to obtain the conversion formulas for transforming a star network into an equivalent data network, we use the value of R1, R2, R3 we just calculated. Now, if you use those values and put those values in this expression, that is multiplication of R1, R2 plus R2 into R3 plus R3 into R1, what you will get? You will get the expression called RA, RB, RC divided by RA plus RB plus RC. It is simple, you just put the value and simplify it, you will get this expression. Now, you need to find the equivalent value of RA. So, what you will do? You will simply divide the equation by the value of R1. So, R1, R2 plus R2, R3 plus R3, R1 have the value of RA, RB, RC divided by RA plus RB plus RC. Now, what is the value of R1? R1 you calculated previously, that is RB, RC divided by RA plus RB plus RC. So, you just put the value RB, RC divided by RA plus RB plus RC. Now, in this case this will cancel out, and also it will cancel out RB, RC from numerator and denominator, and finally what you get is RA. So, that means the value of RA is nothing but R1, R2 plus R2, R3 plus R3, R1 divided by R1. Similarly, you can calculate the value for RB, that is numerator will anyway remain same, and if you divide by R2, you will get the value of RB. For RC, R1, R2 plus R2, R3 plus R3, R1 divided by R3 would be the value. Now, here again the important thing is that you need not to memorize the above equations, you have to just follow the conversion rule. What is that conversion rule? Each resistor in delta network is the sum of all possible products of delta resistors taken two at a time and divided by opposite star resistor. That means, suppose if you are going to find out the value of RA, in the numerator would be the product of sum of all the product of star resistors taken two at a time. That means, the numerator will be R1 R2 plus R2 R3 plus R3 R1. What would come in denominator? Denominator would be opposite star register. So, in this case what is the opposite star register? Opposite star register is R1. So, for the RA you will get R1 R2 plus R2 R3 plus R3 R1 divided by R1, and this is what we got for RA. Simply for RB also you have numerator same, that is R1 R2 plus R2 R3 plus R3 R1 divided by. Now, for RB what is the register opposite to RB in star? That would be R2. So, you will get simply the value of RB. Similarly, for RC it will be R1 R2 plus R2 R3 plus R3 R1 divided by, see the value opposite to RC, that is R3. So, in this way you can easily calculate the value of the corresponding delta elements using star connected elements. Now, to get the idea more clear, let us try to find out the value of the current I in this particular circuit. Now, before that we have to first find out the value of RAB, that is equivalent resistance across terminal AB. Now, if you see this particular circuit, it looks complex, but if you follow the star delta transformation technique which we just discussed, this will be very easy for you to analyze. How? Now, if you see the circuit, there are 2 star networks and 3 delta networks. How? If you see this element and this element, it will create one star sub network. Similarly, this element and again this element will create another star subsection of the network. Similarly, if you see these two and this particular element, it is like a pi, means this is again a delta connected section, and similarly this also is a delta connected section. Third one is this and this is again a delta connected subsection of the network. So, it means that we have 3 delta subnetworks and 2 star subnetworks. Now, to simplify it, you have to just transform one of these so that you can simplify. Now, let us convert the star network comprising of 5, 10 and 20 ohm resistors. So, 5, 10 and 20. So, these are the 3 resistances. Let us put the value R, this is R1, that is 10 ohm, R2 is 20 ohm and R3 is 5 ohm. So, if you have to create equivalent delta, there will be one segment here and third segment would come here. So, what would be the value of this? We just calculated the value for delta element. This would be the the sum of the product of 2 elements, all possible products of 2 elements in a star. So, here what would be the first element? 5 into 10 plus 10 into 20 plus 20 into 5 divided by what we write in the denominator, we write the opposite star element. So, what would be in this case? Opposite star element is 20. For this particular segment, the opposite star element is 20 ohm, right. So, what would be the value of this element? If you simplify, this will become 350 divided by 20 is nothing but 17.5. So, the value of this would be 17.5, right. Similarly, for this segment also you can calculate, anyway this will always remain same. So, you have to simply divide it by 5 ohm, you have to simply divide 350 by 5 ohm. So, this segment value would be 70, and for this again you have to simply divide 350 by opposite element, that is 10 ohm. So, you will get 35. So, what you have got now? You have got these 3 values, that is what we calculated just now. Now, if you see this particular subsection of the network, you can see that these two are in parallel, these two are again in parallel, and these two are again in parallel. So, if you combine both all the parallel elements, what you will get? You will get simply, if you take the equivalent of these two elements, you will get 7.292 ohm. If you take the equivalent of these two elements, you will get 10.5 ohm, and again if you take the equivalent of these two elements, you will get 21 ohm. So, now this is even very simple circuit which you can easily consider for the calculation of equivalent resistance across A and B terminal. So, what you get? You get RAB is nothing but 9.632 ohm. So, these two are in series and their summation would be in parallel with 21 ohm. So, you will simply get the value of RAB, and now what would be the current? Current, you have to just simply divide the resistor, the voltage by equivalent resistance which we have just calculated. So, voltage is 120 volt. If you divide by 9.632, you will get current as 12.458 ampere. Now, let us talk about mesh analysis. This is also one of the important component in our circuit analysis. Why? Because it provides another general procedure for analyzing the circuits using mesh currents. Mesh currents, or you can say loop current, as a circuit variable. So, if you see in this figure, so these currents I1 and I2 are called as a mesh current, and it is different from the branch current, because branch current flows in a particular branch of the circuit, and loop will be same current flowing through a particular loop which we have just saw in this particular case. Now, this is mesh analysis, also called loop analysis, or you can say mesh current method. Now, here instead of element current as circuit variable, we use mesh current as a circuit variable, because it is very convenient and it reduces the number of equations that must be solved simultaneously. Like in this case, if you see, there are only two variables related to mesh current, but if you take the branch variable, you will have one for branch current for R1, similarly one branch current for R3 and one branch current for R2. So, here you have three variables if you use branch current method, while in case of mesh current method, you will have only two variables. So, it means that you can reduce the number of equations required to solve the circuit. Now, there is a little difference between loop and mesh. Loop can be considered as a closed path with no node passed more than once. So, here this is a loop and this is also a loop, because it is not tracing one node at one node two times. But mesh is the loop that does not contain any other loop within it. So, mesh can be considered a special kind of loop which does not contain any other loop within it. Now, what does it mean? Let us see the example for better understanding. In the particular circuit, you will see ABEFA is one mesh and BCDEF is another mesh, but ABCDEFA is not a mesh, ABCDEFA. So, outer loop is not a mesh. Why? Because it contains two loops inside. So, that is why mesh is considered to be a special kind of loop which does not contain any other loop within it. Now, you can simply apply the Kirchhoff voltage law to find the unknown currents. One of the important property of mesh analysis is that mesh analysis is only applicable to the circuit that is planar. Planar means the circuit is the planar which can be drawn in a plane with no branches crossing one another. So, it means that if you see this particular figure, the branches are separate and no any branch is cutting any other branch. While in this particular case, if you see, this is non-planar circuit because the branches are cutting across and it is not in a plane, it is now become a 3-dimensional circuit. So, that is why the mesh analysis cannot be done for these type of circuits, but it can be done for planar circuits. Now, another important thing is that sometimes when you see the circuit, it looks like this circuit, right, and you will see that lot of branches are cutting across. So, at the first instance you will consider it as a non-planar, but if you can redraw the circuit in such a way that it can become a planar circuit, then you can use the mesh current method to analyze it. What does it mean? If you see this particular circuit, then you will see that this 5 ohm is cutting across. Instead of putting 5 ohm like this, if you put 5 ohm as shown in this figure, it will become non-cutting branch. Similarly, 3 ohm, this particular 6 ohm is also can be arranged in this fashion, and if you remove these two and rearrange, you will get eventually a planar circuit. So, you need to analyze the circuit once before doing the mesh analysis, whether it can be converted into a planar circuit or not. So, for this you can utilize the network topology information which we discussed previously. So, when you create the topological network of this circuit, and if you rearrange the nodes and branches in such a way that their connectivity information is not changed, then you can easily find out whether that particular non-planar circuit can be converted into planar circuit or not. And if it can be converted into planar circuit, you can simply run your mesh analysis. Now, what are the various steps to determine the mesh current in the mesh analysis? You have to assign first mesh currents I1, I2, I3 and so on for number of meshes. Suppose in this case there are n mesh, and then you apply Kirchhoff voltage law to each of the n mesh and use Ohm's law to express the voltages in terms of the mesh currents, and then solve the resulting n simultaneous equations to get the mesh currents. Now, one important thing to remember is that although a mesh current may be assigned to each mesh in a arbitrary fashion or in a arbitrary direction, but it is conventional to assume that each mesh current flows clockwise, because this will be easier for you to analyze the circuit and there would be less chances of errors. Like in this case, we have done the we have taken the direction of the mesh currents as clockwise. Now, how you will do the mesh analysis? It is, if you see the mesh analysis technique, it is merely an extension of Kirchhoff's law, because here also you have to apply the Kirchhoff's laws to find out the value of circulating currents. Now, if you consider this particular figure, there you will see that network has 3 circulating currents, that is I1, I2 and I3. Now, all have been assigned a clockwise direction for not to take risk of error, and then we have to analyze these currents which are called mesh currents. So, if you see this circuit and analyze, what you will do? you will use Kirchhoff's voltage law in each mesh, and then you will try to find out what would be the equations for those mesh currents. So, if you see in this figure, the mesh the equation for this particular mesh would be, if you start from here, minus E1 plus I1 minus I2, because here I2 direction would be in this direction, I1 would be in this direction, right. So, for Z2 it will be I1 minus I2 into Z2 plus I1 into Z1. So, if you write, then it will become minus E1 plus I1 minus I2 into Z2 plus I1 Z1 is equal to 0. Now, if you rearrange, what you will get? You will get I1 into Z1 plus Z2 minus I2 Z2 equal to E1, right. Similarly, for these two also you can write here. For I2, what you can write? You can write the summation of all the impedances this current is seeing, that is Z2 plus Z3 plus Z4, and then minus of I1 Z1, because here the I2 is flowing in opposite of I1. So, I1 Z2 with negative sign will come. Similarly, for Z4 also I3 with negative sign will also come. For this particular mesh, what would be the value? This would be I1 I3 into Z5 plus Z4 minus I2 into Z4, because in Z4 I2 is flowing in opposite direction of I3, and then equal to minus of E2. So, now we got these three equations. Next step is that you have to analyze these particular equations and find out the value of current I1, I2 and I3. And the important thing is that the branch currents are determined by taking the phasor sum of mesh currents common to that branch. That means, if you see this figure, for this particular branch, the branch current would be phasor sum of these two. Phasor sum means you have to consider the direction. So, for this particular segment, the branch current would be I1 minus I2. Now, you can now notice that branch currents are different from the mesh currents, and this will be the case unless mesh is an isolated mesh. Now, the question would come, how you will verify whether you have written all the equations which are required for the analysis. You have to take the help of theorem of network topology. So, if you see the theorem of network topology, it says that number of branches are equal to number of loops plus number of nodes minus 1. So, in this particular figure, if you see, you will have 1, 2, 3 nodes and 1, 2, 3, 4 and 5 branches. So, number of nodes are 3, number of branches are 5. So, how many loops are there? Loops in that particular circuit would be equal to 3. That means that 3 independent loops, and therefore, 3 independent equations are required to solve the circuit. So, here you will see that there are 3 independent equations we have created to solve this particular circuit. Now, let us take one example quickly, so that you can understand what we discussed till now. So, if you see this particular circuit and you write the equations for all 3 mesh currents, what you can write here is, for I1 is 3 plus 5 into I1 minus 5 times of I2, because I2 and I1 are in opposite direction, that would be equal to 4. And similarly, for here you will get summation of all the resistances coming in the loop of I2 multiplied by I2 minus 5 into I1 minus 1 into I3 equal to 0. Similarly, for this loop also you can write 1 plus 8, that is 1 plus 8 into I3 minus 1 of I2, because I3 and I2 are in opposite direction, then it is equal to minus 5. Now, if you rearrange, you will get these three equations, and after solving you can get the value of I 1, I 2, I 3 as I 1 would be minus 0.595 ampere, I 2 would be 0.152 ampere, I 3 would be minus of 0.539 ampere. So, similarly you can calculate the value of current in 5 ohm and 1 ohm resistor, because these are the branch currents, and for 5 ohm resistance the branch current would be I 1 minus I 2. So, you will get 0.44 ampere, and current in 1 ohm resistance would be I 2 minus I 3, then it would be 0.69 ampere. Now, in this case we have taken all the current direction as clockwise. Here we have got current in negative with negative sign. That means that our initial direction of current was clockwise, but finally the direction of current is anti-clockwise. So, from this you can get, but for better analysis we first keep all of them in one direction and solve it. So, with this we close our today's session, and we will continue the analysis using mesh analysis in the next session also. Thank you.